Hey everyone, today we're going to be finding areas of triangles and then using that knowledge and our knowledge of finding areas of rectangles in order to find areas of other polygons. So polygons are shapes. They're sided figures that are enclosed. So for example, rectangles and triangles are examples of polygons. So let's start with those triangles. What we have is the area of a triangle. The area of a triangle can be found by multiplying the base times the height and then dividing it by 2. You can also kind of think of it as a fraction of 1/2 base times height. So you can multiply 1/2 by whatever the amount of the base and the height is multiplied together, and you'll get the same answer. This is literally the same equation, just written in 2 different ways. All I can do is put a 1 in here and I'll have this equation. So it's really the same thing. The base and the height of a triangle can be found attached to a right angle. Right angles measure 90 degrees and they look like a perfect L or a backwards L. And they usually have a box in the corner. That is how you know that it's a right angle when it's written on paper. Right angles are going to be super important in this because whatever the right angle or wherever the right angle is where your base and your height's going to be. So there's 3 examples of different triangles that you might see. Because triangles are not always the same, there's not going to be a given height all the time within the triangle, I should say. In this example, there is. We see that there's the right angle right here. The height of a right angle is going to be the line that is going up and down or vertically. So I see that this goes perfectly straight up to the top of my triangle. And the base is going to be the horizontal line, so the side to side line. So my base is going to actually be this entire length here. Your height would be from here to here. Your base would be from here to here. So that's one example of a triangle that you might see. Another example of a triangle that you might see is something that looks like this. This has that right angle physically in it, and I can see that attached to it, going straight up is going to be my height, and then going side to side is going to be my base. Now, some triangles, you don't see that. Instead, what we have is this right angle on the outside. The reason for that is because you really cannot get a good height on this little triangle right here because it's crooked. What we have to do is actually find or create, depending on how advanced in math you're getting. Usually it'll be written for you though. Where the right angle is. So this one, the right angle is drawn for you. Most of the time it will be for you as well. The base is going to be the line that's attached to the horizontal line again. So this would be my base. And my height needs to go straight up from the bottom of the triangle to the top of the triangle. And I see that right here. So we can't just draw our own heights or our own bases. We have to find that right angle where that will literally point us to or show us exactly where the base and the height are. Now there are 3 different types of triangles. There's a right triangle that has the right angle in it. There's also, or that would mean, rewind, that right angle tells us it's a right triangle. So a triangle with a right angle is going to be the right angle in the corner. Another type of triangle is the isosceles triangle. Isosceles triangles are triangles that have exactly 2 equal sides. Books and online will show the lengths of sides sometimes by drawing lines. In this example, I have 1 line through this side and 1 line through this side. That means that they're the same. So these 2 sides of my triangle are going to be the same, and this bottom one is going to be different. And I know that because I have 2 lines down below. And then finally, I have a scalene triangle. A scalene triangle is a triangle that doesn't have any equal sides. And again, I can see that in my drawing. This side only has one line going through it. This side has two, and this side has three. Since none of those number of lines are the same, they're all going to be different. Now I can find the area of different shapes by doing the steps that are down below. So in my example, I have this house looking figure, and my directions are to find the total area of this. So it's not a rectangle, it's not a square, it's not a triangle. Instead, it's a combination of both. So what I'm going to do is my first step, which is to cut, and I have that in quotes. We're not physically going to cut, but we're going to draw the figure into rectangles and triangles. So we have to make sure when we're doing this that we have straight, vertical, and horizontal lines to separate the shapes. That means that we can't draw any diagonals. And we do that because we want to create those right angles. We can't do right angles if we have any diagonal lines. So I have my figure right here. Let me get the right color pen here. There we are. I see that it's a house looking thing. I see that at the top is a start of a triangle, and I can finish that triangle by just putting a straight line going right across. That is a line that is a horizontal, it's straight, and that actually creates my 90-degree angles down below. So with that in mind, I see that I have a triangle on top, and I see that I have a rectangle down below. Yay! I completed my first step. My second step, it says determine the measurements of your new shapes and find the area of all of them. So as I said before, I have two different shapes. I have my triangle and I have my rectangle. Looking at my original figure, I see that I have down below a length of 4. That tells me that since it's a rectangle, that the side opposite is going to be 4 as well. So, got my rectangle drawn here. I have 4 feet on this side. Same thing over here. I have a height of 3 feet. That must mean that the opposite side of my rectangle is 3 feet as well. Now we have the triangle. So the triangle actually shares a side with the rectangle. And since we determined that this side of the rectangle is the same as the other side, that must mean that the bottom of my triangle is the same as what I have right here, which is 4 feet. So when you're cutting up your shapes, a lot of your sides are going to share amounts. So you're gotta really see where these numbers are coming from by looking at how the shapes are divided. From here, you can find the area of each shape. Starting with the triangle, I see that I have a straight line going up from my original drawing. That is 2 feet. And this would have been given to you in your problem. So that is going to be my height. My 4 feet is going to be my base. And again, I know that because technically there's a 90-degree angle right here. So I have my base times my height, and then I'm going to take that amount and divide it by 2. Well, 4 times 2 is equal to 8. And when I divide 8 by 2, I am left with 4 feet squared as my area of my triangle. And then I'm going to do the same type of thing with my rectangle. To find the area of a rectangle, I have to multiply the base times the height. So I have 4 as my base, 3 times my height. You can also think of it as length times width as well. And 4 times 3 equals 12. So that is 12 feet squared. And we are almost done. That last and final step, add the areas together and write the proper label. So we said that the area of our triangle was going to be 4 because we did 8 times 2 divided by 2. Nope, we didn't do 8 times 2 divided by 2. What did we do? Let's look back. 4 times 2 divided by 2. That's it. 4 times 2 divided by 2. And we had 4. And then we did base times height. 3 times 4 to get our area of our rectangle, and that equaled 12. Add those together. 4 plus 12 does equal 16. So the total area of that figure is going to be 16 feet squared. So the whole process of this is to take parts that you know, find the areas of them, and add them together. So you do this process of breaking things down and putting them back together without even thinking. We've done that in the past. We're now going to just apply that to polygons. So if you have any questions, please let me know.